Hi, Math 127 students. Today we're working on section 8.2, which is law of sines. The first thing I have up here is a couple of definitions and terms for triangles. You might have seen these already in some previous geometry classes, and you won't be tested on these, but I just wanted to go over these because you might see them throughout this section. So the first one is an oblique triangle. This is a triangle without a right angle. So far everything we've done in this class up to this point, we've always worked with right triangles. What we're going to do now in section 8.2 and 8.3 is we're going to work on solving oblique triangles, so triangles without a right angle. And this requires one of two things, either something called the law of sines or the law of cosines. So in 8.2 we'll do law of sines, and in 8.3 we'll do law of cosines. These next two sections are going to be particularly useful to you in your physics and engineering classes because in the real world, everything's not a right triangle. So this is going to help you learn how to solve for missing angles and missing sides in any triangle whatsoever. So out of the oblique triangles, there are two other types, two other classifications. Acute means all angles are less than 90 degrees, and obtuse means one angle is greater than 90 degrees. Of course, we can't have two angles greater than 90, otherwise the sum of the angles can't be 180. These three terms refer to the sides. So these are all terms referring to the angles, and these are terms referring to the sides. So a scalene triangle has three unequal sides. An isosceles triangle has two equal sides, and an equilateral triangle has all three sides equal. Again, you're not going to be tested on these terms, but I just wanted to put them all in one place for you. So as I mentioned in section 8.2 and 8.3, we're going to solve oblique triangles. We have two different formulas that we're going to use to solve oblique triangles. In section 8.2, we'll use what's called the law of sines. And in section 8.3, we're going to use what's called the law of cosines. Now, I made a table here of when you should use each formula, but I don't think you should memorize these different cases unless you really want to. What I'll do as we're going through these problems is I'll talk you through why you'd be using which formula. So here the given information is angle, side, angle, so two angles and the side in between them. Here the given information is two angles and a side opposite. This is the case, you see I have this highlighted, this is the one you do need to pay specific attention to. This is called the ambiguous case, and I'll talk about that more in part 2 of this lecture, but this is side, side, angle, and the reason why this is ambiguous, this is the only possible or the only scenario where our possible outcome can be no solution, one solution, or two solutions. Every other case for this entire chapter, you should always get one answer. Law of cosines, we're going to use in the case where we have side angle side or side side side. So in general, and we'll talk through this as we're going through examples, in order to use law of sines, you need to know an angle and one of the opposite sides. So here we'd find the third angle quickly, and then we know the opposite side. Here we know an angle on the opposite side. Here we know an angle and an opposite side. Here we have an angle, no opposite side. Here we don't know any angles. So in general, law of sines, you need to know an angle and an opposite side. Also, law of sines is much easier than law of cosines. So my personal suggestion to you would be to try and ask yourself first, can you use law of sines? If so, great. If not, then you should be using law of cosines. So first I want to derive law of sines for you, and then we'll do some examples. So what we're looking at is an oblique triangle, so law of sines. So here's an oblique triangle. The way we label an oblique triangle is our angles are always capital A, capital B, and capital C. And then the sides across from those angles get the same letter name, but lowercase. And these can be oriented in any which way. So here's A, C, B, and you can see the sides across. So remember, these are freestanding geometric objects. Okay, so what we want to do is use what we know about trigonometry to come up with a way. I've already given it away. We're going to use sine. So what I'm going to do here is I'm going to drop a perpendicular in the middle of this triangle, and I'm going to call this H for height. Now what I'm going to do is focus on this triangle and then focus on this triangle. So first let's look at this one on the left. B is split up, so what we know here, we don't know what part of B is on either side of this height, but the sides we know is H, and the side we know here is C. So what I'm going to set up is sine of angle A is equal to the opposite, which is H, over the hypotenuse, which is C. Now what I want to do is look at this triangle on the right, and we see that sine of angle C is equal to the opposite, which is H, over the hypotenuse of that triangle, which is A. Now we see in both of these formulas that we have H. So what I'm going to do is solve them both for H. So here I get H is equal to C sine of A, and here I get H is equal to A sine of C. Then since these are both equal to H, I'm going to set them equal to each other. So I have C sine of A is equal to A sine of C. Next step, I'll divide both sides by lowercase c and by lowercase a. That gives me sine of A over A is equal to sine of C over C. This is the law of sines. We can form these two right triangles by splitting up any of these angles. And so the full version of law of sines is 3 different equations, but we combine it into one. So law of sines says sine of A over A is equal to sine of B over B, which is equal to sine of C over C. So we already proved A and C. We would have similar proofs for A, B, and B and C. So this is actually 3 equations in one. Here's the first one, that's the one we proved. Here's the second one, and then here's the third one. So 3 equations compacted into one. So let's go ahead and just do a few examples using law of sines. And you will need your calculator, so make sure you have that out so you can follow along with me. Okay, so here we're asked to solve the triangle, and we're given that angle B is 45 degrees, angle C is 95 degrees, and side C is 5. So the first thing we notice is that we do have an angle on the side across from it. So that clues us in that we need to use law of sines. In this section, all of the problems will use law of sines, but you should start thinking about these things because when you get to the exam, you're not going to be told which formula to use, and you'll need to figure that out. So to solve the triangle means find the missing angles and the missing sides. So the first thing we'll do is find angle A. That's the easiest thing to do. We know that all 3 angles in a triangle always add up to 180. So that means that A is 180 minus what we already have filled in. So that's a 45 and a 95, which means angle A is 40 degrees. Okay, the next thing we want to do is start by finding side A. Now be very careful here. We are not able to use Pythagorean theorem anytime that we are working with an oblique triangle. So what I want to do to find side A, I want to set up an equation where A is my only unknown. So because we want A to be one of our unknowns, the portion of the law of sines we're going to use, first of all, we know we have to use sine of A over A so that I can solve for little a. We know what angle A is, we just solve for that. Now we have 2 options. We can either set this equal to sine of B over B or sine of C over C. So what we want to do is look at the triangle and see what information we're given. Because we're given angle C and side C, we have to use sine of C over C. If in error you had set up sine of B over B, pretty quickly you would realize that you have 2 unknowns in this equation and you're not going to be able to solve it. Okay, so our next step here, let's plug everything in. We have sine of 40 over A is what we're looking for, is equal to sine of 95 over 5. We need to solve for A, so I'm going to multiply both sides by A, get that out of the denominator there. So I get sine of 40 is equal to A sine of 95 divided by 5. I am trying to solve for A, so I want to get rid of this. This is just some number, so I'm going to multiply by the reciprocal here. These cancel. That gives me A is equal to 5 times sine of 40 over sine of 95. All right, so in your calculator, if you're following along with me, make sure 1, you're in degrees. And then 2, just to type this in, you hit 5 times sine of 40 divided by sine of 95. Should be pretty straightforward here. You should get 3.23. If you're not getting the same answers as me, make sure you ask for help either from me, from your TA, from the Math Center, or Google how to enter sine on a TI-30 or whatever calculator you have. The last step here is we want to find side B. So I'll do that right here, find side B. So again, be careful, you cannot use Pythagorean theorem here. No Pythagorean theorem. That only works for right triangles, okay, so be careful. So to find B, we know we want to set up sine of B over B. And then we can either set this equal to sine of A over A or C over C because we know both of those things. I'm going to use the information that was given in the problem, so I'm going to set that equal to sine of C over C. Next step, fill in our values. So sine of 45 over side B is equal to sine of 95 over side C, which is 5. We're solving for B, so my next step is to multiply both sides by B. I get sine of 45 is equal to B sine of 95 over 5. Next step to solve for B, I'm going to multiply by the reciprocal here. That gives me B is equal to 5 sine of 45 over sine of 95. Putting this in your calculator, we get 3.55. Okay, so let's zoom back out and let's look at our overall problem, and let's just check our answers. So what you want to do here, once you get your solutions, you want to check that your answers make sense. So the first thing we should check is that all 3 angles add up to 180, and they do. The next thing we should check is that the scale of our sides makes sense. So our sides are 3.2, 3.5, and 5, so yeah, that makes sense. You want to be on the lookout for things like sides 3, 5, and maybe 150, okay? That doesn't make sense. The other thing you want to check is that the smallest angle is opposite the smallest side, middle angle opposite middle side, largest angle opposite largest side. That looks correct. And then it is true that the closer the angles are to each other, the closer the sides are. So for example, A and B are 40 and 45, and side A and side B are 3.2 and 3.5. So because these angles are close to each other, these sides are also going to be close to each other in measurement. All right, let's do another one. Okay, so next example here, I have angle C is 57, angle B is 48 degrees, side A is 10. So we're on angle side angle here. So the first thing we should do is find the third angle. Anytime we already know 2 angles, finding the third angle is really quick. We know that the 3 angles always add up to 180, so that means that angle A is 180 minus 57 minus 48, which is 75. The next thing I want to do is start finding my other side. So let's work on finding side B. So to find side B, we set up sine of B over little b. And then we have 2 choices here. We can either set this equal to sine of A over A or equal to sine of C over C. So what we want to do is make sure that what we're looking for is our only unknown. So if we look at this information, because we're given angle A, we found angle A, and we're given side A, I need to set this equal to sine of A over A. And this is really forgiving. If instead you did C, you'd get 2 unknowns really quickly, and that just clues you in to proceed in a different manner there. Okay, next up, let's fill in our info. So we have sine of 48 over little b, that's what we're looking for, is equal to sine of A, we figured out was 75, over little a, which is 10. Okay, so on the last problem, I showed you how to solve this working the long way, multiplying both sides by b and then multiplying by the reciprocal. You're always welcome to work it out the long way, but if you kind of see the pattern here, or you know about the shortcuts across the equal sign, you're welcome to use those. Here we get b is equal to 10 sine of 48 over sine of 75. Okay, so if you want to see how the shortcut works, what you want to do is picture if b is on the denominator, we're going to multiply both sides by b, so that puts b up here. And then I have to multiply both sides by 10, so that puts 10 up here in front of the 48. And then I need to divide by 75, so the 75 goes there. Okay, so you're welcome to use those shortcuts, or you can always do it the long way if you want. Throw this in your calculator, you should get 7.69. Okay, last thing we need to do is find side C. And again, be very careful here. You cannot use Pythagorean theorem. Pythagorean theorem only applies to right triangles where A and B are the legs and C is the hypotenuse. Here, we don't have legs and hypotenuse because there's no 90-degree angle, so you cannot use Pythagorean theorem on oblique triangles, so be very careful with that. So I'm going to set up sine of C over little c is equal to sine of A over A. Let's fill in our info. So I have sine of 57 degrees over C is equal to sine of 75 degrees over 10. So again, if you want to use these shortcuts, or you're welcome to work it out the long way, if you can't visualize these shortcuts, that's totally fine. You get C is equal to 10 sine of 57 over sine of 75. Putting this in your calculator, you get 8.68. All right, so again, we should check a few things. First, that there are three angles add up to 180 degrees, and they do. Next is that the smallest angle is opposite the smallest side, middle angle opposite middle side, and largest angle opposite largest side, and that all looks great. We should check the scale of our sides. So we got 7, 8, and 10, so that looks good. And then it is true that the closer the angles are to each other in measurement, the closer the sides should be. So if we look at these two angles, B and C, they're 48 and 57. And then we look at sides B and C, they're 7 and 8. So yeah, that makes sense. So we can check all of these things to make sure that we're on the right track. Let's do one more. All right, so here we're asked to solve the triangle. Let me zoom in a little bit here. Okay, we got angle A is 35, angle B is 15. We need to find angle C, and we have side C is 5. So here we're in the case angle, side, angle. So the first thing we should do is find our third angle. We know that our three angles in a triangle always add up to 180. So we have that angle C is 180 minus 35 minus 15, which is 130. Next up, let's work on finding our other side. So I'll find side A. So if I want to find side A, I know I need to set up sine of A over A. Then we have two options here. I can set this equal to sine of B over B or sine of C over C. So if we look at the triangle, the information that we're given is angle C and side C. We don't know what side B is. So we have to use sine of C over little c here. And again, this is forgiving. If you set this up wrong with B, you'll get an equation with two unknowns. It'll just clue you in to go back and work this differently. Okay, so let's fill in what we have. We have sine of 35 over little a, which is what I'm solving for, is equal to sine of angle C, which we figured out was 130 over side C, which is 5. Next step, you're welcome to do this the long way or the shortcut way. Solve for A. We get that A is equal to 5 sine of 35 over sine of 130, which is 3.74. Last one, let's find side B. And again, remember, you cannot use Pythagorean theorem on oblique triangles, Pythagorean theorem only applies to right triangles. So to find side B, I'm going to set up sine of B over little b is equal to sine of C over C. Now at this point, since we do know A, you could set up sine of A over A if you wanted to, but I like to use the information given by the problem. So let's do it. We get sine of 15 degrees over side B is equal to sine of 130 over 5. Solving for B, we'll multiply both sides by B, then multiply by this reciprocal. We get that B is equal to 5 sine of 15 over sine of 130, which is 1.69. Okay, coming back up to our original problem up here, things we should check. We should check that our 3 angles add up to 180. This adds up to 50, plus 130 is 180, looks good. The next thing we should check is the smallest angles opposite the smallest side, middle angle opposite middle side, largest angle opposite largest side. So that all tracks. We should check that the scale of our sides is correct. We got 1, 3, and 5, so that looks good. So everything looks great here. So you notice in these last 3 problems, I always got one solution. Okay, so on any of these problems, you should always get exactly one solution. There is the ambiguous case that I mentioned at the beginning of this lecture, and we'll talk about that in part 2. Hi, Math 127 students. Today we are continuing with our discussion of law of sines. So we have one case called the ambiguous case. Ambiguous means we don't know. So this one case is the ambiguous case because we don't know the outcome until we actually work through the problem. So the way you remember which case is going to be the ambiguous case is this is side angle. And without cussing on camera here, let me tell you that this case is a pain in my angle side. Angle side. See what I did there? So think about whenever you see this side angle side, this one's going to be a pain in your angle side. That should clue you in, you're in the ambiguous case. This is the only case where you don't know what the outcome is. Every other problem for all of section 8.1, 8.2, 8.3, you will get exactly one answer and you will always get an answer. This is the only case where you might not get an answer. So the 3 possible outcomes are no solution, no triangle, 1 triangle, or 2 triangles. So I showed you, I have pictures here showing what the different outcomes look like. So the first one, if we're given angle side, it's possible that the given information actually doesn't form a triangle. So for example, if this side has length 7 and this side has length 1, maybe it actually doesn't even connect. All of the other cases we saw, we were given information that definitely did form a triangle. One possibility, we form 1 triangle. The second possibility is that the information actually forms 2 triangles. So first, if you take a look at this green triangle, here's angle side that's given. You can picture taking this side of the triangle and swinging it out, and it forms 2 different triangles. Okay, so these are our 3 possible outcomes. So as far as when we're doing calculations, what's going to happen is we're only given 1 angle in this case. So since we're only given 1 angle, we're going to end up using inverse sine because we're using law of sines. So we're going to use inverse sine to find the second angle. Now remember, inverse sine, when we define this, that's restricted to give us outputs between negative pi over 2 and positive pi over 2, or negative 90 degrees and positive 90 degrees. So on the calculator is only going to give us the solution in quadrant 1, right? We don't have negative angles, so the quadrant 4 is never going to happen. Calculator is only going to tell us the solution in quadrant 1, but since this is an oblique triangle, it's actually possible that our angles are greater than 90. We didn't have to worry about this in section 8.1 when we were only dealing with right triangles, but here with oblique triangles, we do need to consider this. So we also need to consider the solution in quadrant 2, and in general, the possible angle in quadrant 2 is going to be 180 degrees minus whatever you get from your calculator. And I'll show you as we're working through these problems how we decide if we get no triangle, 1 triangle, or 2 triangles. My first example here, we are asked to solve the triangle. We're given that angle A is 40 degrees, side B is 2, and side A is 3. So what you want to think about this, you want to recognize this is our angle side side. This is our ambiguous case. So here's angle side side. Or the other way of kind of looking at this is because they haven't given us either of these other two angles, this triangle actually isn't set in place, right? This side can be kind of anywhere because we're only given one angle measurement. So let's proceed with law of sines. So the first thing I'm going to do is work on finding these angles. So because we're given side B, I'm going to start by finding angle B. So we're using law of sine, so I need to set up sine of B over B is equal to, and then because we're given A and A, we're going to set up sine of A over side A. Next step, fill in our information. So I have sine of B over little b, which is 2, is equal to sine of 40 over little a, which is 3. Next step here, we're working on solving for b. So my next step is to multiply both sides by 2. So I have sine of b is equal to 2 times sine of 40 divided by 3. Next step, you want to enter this part on the right side in your calculator. So type this into your calculator. Notice that this divided by 3 is under this entire sine of 40. So if your calculator automatically gives you a parenthesis right here, you need to close it to tell your calculator that 3 is outside of that expression. So you should get that this part is equal to 0.4285. Next step, we're solving for b, so we're going to take inverse sine of both sides of the equation. Inverse sine of both sides of the equation. Okay, so sine and inverse sine cancel, and we get that b is equal to inverse sine of 0.4285. All right, so on your calculator, inverse sine button should be right above your sine button. Go ahead and hit inverse sine of 0.4285. You should get 25.4 degrees. Now, here's where we have to do some thinking. Your calculator is only going to give you the solution in quadrant 1. So what we need to do is consider the possibility in quadrant 2. We never have to worry about quadrant 3, right? The angles in a triangle add up to 180, so it's impossible for one of our angles to be greater than 180, so we never have to worry about 3. And we also never have to worry about 4 because we don't need it. We can't have a negative angle, and we certainly can't have something between 270 and 360. So we only have to worry about quadrant 1 or quadrant 2. Okay, so in general, the angle in quadrant 2 is going to be 180 degrees minus this angle. So what I'm going to do here is put a little b1 for our solution in quadrant 1 and then b2. This is 180 minus 25.4, which is 154.6. The reason why this works out this way, 180 minus that angle, is because all we're doing is drawing matching triangles. So our first solution was 25.4. We want to draw a matching triangle in the second quadrant, also 25.4. But our angle measurement is, of course, the angle in standard position from here to here. So it's always going to be 180 minus what you get in the calculator. Okay, so now it's up to us to determine if both of these are feasible. So the way we determine if they're both feasible, let's go back up to our picture. We have that one of our angles is 40. So what we want to do is ask ourselves, are these both feasible? Are these allowed? So first one, 25. So is it okay for one angle to be 40 and for angle B to be 25? Sure, that's fine. What we want to check is that they don't exceed 180. Okay, so let's look at the next one. B2, is it possible for A to be 40 and B to be 154? The answer is no way, right? 40 plus 154, that's 194. That exceeds 180, so this is not possible. Our only solution is that B is equal to 25.4. And I'll show you some different outcomes in our upcoming examples. All right, once we have angle B, the next thing we should do is find angle C, which we can do really quickly. We know that once we have two angles to find the third angle, since they add up to 180, C is 180 minus 40 minus 25.4, which is 114.6. The last thing I want to do is find side C using law of sines. So I'm setting up sine of angle C over side C is equal to sine of, and we can either do A or B at this point. I typically like to use the information that's originally given in the problem. So I have sine of 114.6 over side C is equal to sine of 40 over side A, which is 3. We're solving for C, so again, you're welcome to do this in as many steps as you need to, but you might be recognizing this pattern by now. I'm going to multiply both sides by C and then multiply both sides by the reciprocal, giving me C is equal to 3 sine of 114.6 over sine of 40, which is 4.24. Once you get your answers, go back up to your original triangle, make sure that all 3 angles add up to 180, make sure that smallest angle opposite smallest side, middle angle opposite middle side, largest angle opposite largest side, and that the scale of the sides makes sense. So we got 2, 3, and 4.2, looks pretty good. Next one. There we go. Here we have angle C is 50, side C is 1, and side A is 2. So again, what you want to think about is in order, we have angle, side, side. So this is the case where we need to pay attention to what our possible outcome is. So the first thing I want to do is start by finding these angles. Since I have side A, I need to start by finding angle A. So I'll start by finding angle A. So I set up sine of A over A is equal to the information we're given, so sine of C over C. Next step is to fill in our values. So we have sine of A over 2 is equal to sine of 50 over 1. Next step, multiply both sides by 2. I get sine of A is equal to 2 sine of 50. Of course, the divided by 1 we don't need to write. Okay, we need to solve for A, so we're going to end up taking the inverse sine of both sides. So what we want to do is plug this into our calculator first. So I have sine of A is equal to 2 sine of 50 is equal to 1.53. Now, at this point, you might find an error. So here we have sine of some angle that is equal to 1.53. Remember what our sine graph looks like? Looks like this. Our maximum y value is 1 and our minimum y value is -1. That means no matter what our input is, our output sine of anything has to be between -1 and 1. Now this is not between -1 and 1, so at this point we actually know no solution. No solution. Now what if you hadn't recognized that there was no solution? You would keep going with the problem. So the next step would be to take the inverse sine of both sides. So you'd get A is equal to inverse sine of 1.53. On your calculator, go ahead and push inverse sine of 1.53. Your calculator should tell you error. Okay, so if you see an error, that means no solution. So what happened here? My picture was so convincing. Now, if you look at my picture, I have this side labeled as 2 and this side labeled as 1. Clearly, this is not twice as long as this. So if we were to draw this triangle to scale, it would actually look like this, right? This side has length 2. Here's my 50-degree angle, and this side only has length 1. So the information that the problem provided to us actually doesn't form a triangle. So you have to be careful here. The pictures can be misleading. Usually on these types of problems, instead of giving you a picture, they'll tell you side A is 2, side C is 1, angle C is 50. And then once you compute this out, you'll realize it doesn't actually form a triangle. Okay, so sometimes we get no solution. Oh, so on this one, no solution, no triangle. So our answer is no solution. This forms no triangles. Next one. Let's solve the triangle. Here I have angle B is 20, side B is 5, side C is 7. So maybe this one looks a little bit more convincing that this side is 5 and this side is 7. We'll see when we get going. So the first thing I want to do is start by finding angle C. Because we have side C, we need to find this angle C first. If you accidentally try to find A first really quickly, you'll realize you have an equation with two unknowns. So let's find angle C. We set up sine of C over little c is equal to the information we're given, so sine of B over little b. Next step, let's fill in our information. So I have sine of C over 7 is equal to sine of 20 over 5. We're solving for C, so the next thing I want to do is multiply both sides by 7. I get sine of C is equal to 7 sine of 20 over 5. The next thing we're going to do is we'll end up taking inverse sine of both sides. So before we do that, let's put this part in our calculator. We get sine of C is equal to 0.4788. So it looks good so far. That's between -1 and 1, so we can proceed. Our next step is to take the inverse side of both sides. So we get C is equal to inverse sine of 0.4788. In your calculator, plug this in. You get 28.6 degrees. Remember, this is our solution only in quadrant 1. So it's still up to us to find the solution in quadrant 2 and ask ourselves if it is feasible. So here I'd like to put a little C sub 1, indicating that's my solution in quadrant 1. The solution in quadrant 2, we have to decide if this works out or not, is always going to be 180 minus what our calculator gives us. So that is 151.4. Again, the reason why this works is we're drawing matching triangles. So our calculator gave us this one, but we still need to find the one in quadrant 2. So the one in quadrant 2 is this angle in standard position, which is 180 minus 28.6. All right, so now we have to decide, are these both feasible? So we go back to our picture of our triangle up here. What we want to do is make sure that the angles don't exceed 180. So B is 20, C is 28.6. Sure, no problem. Next one, B is 20, C is 151.4. Sure, no problem. Right, that's only 171, so that does not exceed 180. So these are both feasible. So we actually get 2 triangles. Now, the challenging part is once we have the information that we get 2 triangles, we actually have to solve the rest of this problem twice. So what I'm going to do is start on a new page, and I'm going to put a line right down the middle of the page. We're going to have our first triangle and our second triangle. So our first triangle, we had that C1 was 28.6. And our second triangle, we had that C2 was 151.4. Okay, so what I'm going to do is solve both of these triangles, and then we'll draw a picture and we'll see what this actually looked like. Okay, so I know what C is. Now I need to find A, and now I'm going to call all of these with a little subscript 1 to indicate that's my first solution. So to find A1, we know what B and C are. So A is 180 minus the other angles we already had filled in, which is 131.4. The last thing we need to do is find side A. So find little side A. And again, I'm going to call it A1. So I'm going to set up sine of A1 over side A1 is equal to sine of B over B. You notice here I didn't put the subscripts on the B because the B is set by the problem, so it's going to be the same on both. So I have sine of 131.4 over A1 is equal to sine of 20 over 5. I'm solving for A1, so I'll multiply both sides by A1 and then multiply both sides by this reciprocal. giving me that A1 is equal to 5 times sine of 131.4 over sine of 20. Putting that in our calculator, we get 10.97. So our first solution is A1 was 131.4, C1 was 28.6, and side A was 10.97. Now we have to do the same thing for this. So I'll do this one a little bit quicker because it follows the same steps. So I'm sorry, let me write this as capital A2 is 180 minus the other two angles. So we'll subtract the 20 and the 151.4 we already have filled in, and we get that A2 is 8.6 degrees. Next up, we'll find side A2. So I set up sine of A2 over side A2 is equal to sine of B over B. And we proceed in the same manner. And we get that side A2 is 2.19. So our second solution here is that A2 is 8.6, C2 is 151.4, and side A2 is 2.19. So let's take a look at our picture and see how this actually worked out. So the original picture that we were given looked something like this. We had that angle B was 20, angle A we didn't know, angle C we didn't know. We had that B is 5 and C is 7. Okay, so our first solution with A being 131.4 looks like this. And again, my angle measurements aren't quite correct in here, not quite to scale. The second possibility here, I'll color code these for you, is that A is a really, really small angle. So what you can picture is that we actually took this side and we actually hinge it in. And our second triangle is this triangle. So this triangle still satisfies the original information given, that B is 20, C is 7, and side B is 5. But this triangle has A as a really small angle and C as a really large angle. So you can see that that given information actually yields two different possible outcomes. Let's do a couple more. Next one here, let's solve the triangle. I have angle A is 70, side A is 8, and side B is 10. So again, what you want to recognize is that when you're given angle side, this is the ambiguous case, right? I painted my angle side, and I want to be on the lookout for 0, 1, or 2 triangles. Okay, so the next thing I'll do is start by finding angle B. The reason why I'm starting with angle B and not angle C is because we were given the side B. So I set up sine of B over little b is equal to sine of A over little a. So I have sine of B over 10 is equal to sine of 70 over 8. We're solving for B, so my next step is multiply both sides by 10. Next step, we're going to be using inverse sine of both sides. So I'm going to put this part in my calculator. So I get sine of B is equal to 1.17. All right, right here, we have a problem. Let's stop. We know what our graph of sine looks like. It looks something like this. The maximum y value is 1, the minimum y value is -1. So we're looking for an angle whose sine is 1.17. That's greater than 1. That's impossible. So at this point, there's no solution, which means there's no triangle. If you hadn't had recognized that was a problem, the next step you would have taken would be to take the inverse sine of both sides. And you would have b is equal to inverse sine of 1.17. Go ahead and give this a try in your calculator if you're following along with me. Your calculator is going to tell you error. So what's happened here? My picture is way off. My picture is super misleading. Look at how I have this angle labeled. This angle A I have labeled as 70. This angle is maybe 40 degrees. So let's try this a little bit more to scale and see what went wrong. So here's our side B that's 10. 70 is going to be way up here. 70. And then A is 8. Maybe it looks like that. And it actually doesn't actually reach to connect. So this does not form a triangle. Okay, so this picture is very misleading. And if you look at this, this is certainly not a 70-degree angle. This angle is so big that this doesn't actually form a triangle with the given information. Let's do one more. So let's solve the triangle. Here we're given angle A is 70, side A is 7, and side B is 5. This one, maybe my picture looks a little bit better, right? This looks closer to 70, and if this is 5, then sure, this is 7. So this one looks a little bit better, but we'll see. So we're going to start by finding angle B. I set up sine of B over little b is equal to sine of A over little a. Next step, we'll fill out our information. So I have sine of B over 5 is equal to sine of 70 over 7. We're solving for B, so my next step is multiply both sides by 5. So I have sine of B is equal to 5 times sine of 70 over 7. We'll plug this into the calculator. So we get sine of B is equal to 0.6712. Next step, we'll take inverse sine of both sides. So we get that B is equal to inverse sine of 0.6712, which gives us our solution in the first quadrant is 42.2 degrees. This is our solution in quadrant 1. Now remember, from the previous problems, our calculator is only going to tell us the solution in quadrant 1. It's up to us to find the solution in quadrant 2 and ask ourselves, is it feasible? My video is a little blurry here. Let me try this again, see if we can get it to refocus. There we go, much better. So our solution in quadrant 2, as we've seen from the previous problems, to get those, what I'm going to do is take 180 and subtract the answer my calculator gave me. So the solution in quadrant 2 is 137.8. So again, the reason why this works is because our calculator tells us this answer, but we still have to consider this angle. So that angle in the second quadrant is 180 minus 42.2. All right, so the way we determine if these are feasible, we have to go back up to our original triangle. The angle we have filled in up here is angle A is 70. So we ask ourselves, are these angles okay? We want to make sure we don't exceed 180. So the first one should always work. So 70 plus 42 does not exceed 180, so that's fine. The next one, 70 plus 137, that is way more than 180. So this one does not work. Our only possibility is 42.2, so I'm just going to call that B if we only have one possibility. So only one triangle. So the next thing we want to do is find angle C. We know that the three angles add up to 180, so C is 180 minus 70 minus 42.2, which is 67.8. The last thing I need to do is find side C. So I set up sine of C over little c is equal to sine of A over little a. So I have sine of 67.8 over C is equal to sine of 70 over 7. Solving for C, we multiply both sides by C, then multiply both sides by this reciprocal. I get that C is 7 times sine of 67.8 all over sine of 70, which is 6.90. So once you get your answers, of course, you want to check the things we've been checking on all the previous problems, that the three angles add up to 180. We want to check smallest angle opposite smallest side, middle angle opposite middle side, largest angle opposite largest side, and that the scale of our sides make sense. So we got sides that are 5, 6.9, and 7. So sure, that makes sense. And the closer the angles are to each other, the closer the sides will be. So if you look at angle A and angle A and angle C, angle A is 70, angle C is 67. So those are pretty close. Side A is 7 and side C is 6.9. So those are pretty close because the angle measurements across from them are also close.